Hello and welcome to Alpistech. Today we will discuss and create the Kubernetes cluster with Kubeadm on AWS EC2 instances. For this purpose, we will use the AWS account, EC2 instances, and the Kubeadm and kubectl. And once the cluster is ready, then we will deploy the Nginx pod and deployments on this cluster. So let's jump to the AWS console and creating the AWS EC2 instances. So first of all, this is the AWS console, and we will move to the EC2 instance console. And here we will create two EC2 instances, one for the as a master. We will declare one instance as a master, and we will declare the second instance as a worker node. So let's create two Ubuntu instances on any region which you are comfortable to create it on. So let's click on the launch instances, and here I will select two instances and writing the name K8 cluster. We will rename the each instance once it's ready. So for this lab, we will select the Ubuntu 22.04 is fine for this lab. And one important thing is that we need to create the cluster. We should select the T3 level instance. T3 medium, T2 medium, it's fine because T3 medium is having a 2 vCPUs and 4 GB memory. So we should select T3 or greater than the T3 type of the instance. We should select the key pair. I already have the key in my laptop, so I will select this key and everything will remain same. But one thing I need to highlight it here is that if you are creating your cluster for the production or any proper application deployment purposes, so you have to create a separate proper VPC, not using the default VPC, and create a private and public subnets according to your feasibility. So I'm just for this lab, this is a demo session. So I'm just creating and selecting the default VPC. So everything is fine for creating. So click on the launch instance and it will take around 2 to 3 minutes to properly complete and in a running state. So meanwhile, let me rename both of the machines. One machine I will declare as a master, K8 master. I will declare this one as a control plane, and the second one I will declare as a worker node. So now we should properly access both of the instances using the terminal. So let me open my terminal and then we will proceed. Okay, so both of the terminals are ready because we have two EC2 instances. So I have created two tabs on my terminal, and let me copy the public IP address of my master node and SSH-I. My key name is this, open at the rate of this IP address. And this is the fresh machine. So just one time you need to enter the yes. Okay, so let me copy this worker node IP address. So there. Okay, so both of the machines are accessible now. So once everything is ready, first of all, I preferably doing this thing. It's not important or it's not compulsory to do that, but for better understanding, I personally prefer to rename the host name of each machine so we can easily properly working on. It's not easy to remember these private IP addresses, so I should rename the host name so we can properly use it. So we run this command sudo hostname master, but to properly impact getting the result, we have to restart our session. I'm just quitting out from this instance and reconnecting it. When we will properly connect it, then you can see that the host name of this machine is now master. So for doing the same thing on the worker node as well, so run the sudo hostname and we will call as worker. Once it's done, we quit it and then we will connect the machine again. And now you can see that the machine name is now worker. Okay, so so now both machines are ready. Now we will I have copied the commands in another screen. I will just copy and paste both of the all of the commands on both of these machines, and I will explain step by step to you. First of all, we should become the sudo user. It's good to become a sudo user, root user. So we can't add the sudo command on each with the each command. So it's good. So first of all, let's update packages, run the packages update command on both machines. Once it's done, then we will move on to the other thing. And first of all, once the updation process is done, we should install the Docker on both of these machines. So I'm doing the same thing on both of the machines. So it's a master, it's working. So now I'm back to the worker node and I run the same Docker installation command, and I will share these commands in the description. So you will copy and use it. So once the Docker process is done, it's installed. We just need to start the process with a systemctl start Docker, and we will enable the Docker process as well. And once it's done here as well, we will run the same thing, systemctl start Docker, and enable it as well. Okay, so the Docker machines, Docker is running. Let me show you the Docker status as well. And you can see that Docker is running. And on the other machine, you can see that it should be running here as well. Okay, so it's running. So once the Docker is installation is done, now we will run few more commands to install the Kubeadm on the both machines. Now we will do the same thing on the both machines, on a worker and the master node as well. So this is the command which I'm running to install the Kubeadm. So first of all, I'm just curl the package, and now I'm just updating the packages because we have just downloaded and getting the latest packages of the Kubeadm. Now we are updating it. And now once the updation process is done, now we are properly installing the kubectl and the Kubeadm. You can see that 1.20 Kubeadm version we are using. And for the kubectl is the command line tool for the Kubernetes. So same thing I'm doing on the worker node as well. Meanwhile, it's installing the Kubeadm on the master node. So first of all, I'm running the curl command, and after that, I will run the echo, and now I will update the packages. Once the updation is done, then we will install the Kubeadm. Okay, so it's installing here as well. Okay, on a master node, the Kubeadm is ready. Kubeadm is installed, but on the master node, we just first of all, whenever we first time install the Kubeadm, we have to initialize it. So we will run the Kubeadm init command. It will initialize the Kubeadm processes. Once this command is completed, it's will properly initiated, then we will have one or two, three different commands. It will suggest us few commands to add the config of the Kubernetes, and then we will able to connect with our cluster. So it will take around few minutes. So we have to wait. But one thing I should highlight is that we don't need to initialize the kube init on a worker node at the moment, because it's a master node. We just initialize it here, and we will connect the worker node with the master node using the token. I will explain the token in a upcoming session. So, okay, so you can see that here it's done successfully. You can see that the Kubernetes control plane is ready, it's installed. But these are the three commands which we have to run it to connect with the Kubernetes cluster. And second important thing is that you should exit it from as a root, and you have to run these commands as a user, not as a root. So first of all, I will quit from the root user, and then I will run these commands. Because you can see that if you read this line to start using your cluster, you need to run the following as a regular user, not a root user. It's having a root user a command as well, but it's not a best practice. It's good practice is that you have to quit it from the root, and then you will run these three commands, and it will copy the kubeconfig in your user home directory, and then you can easily able to connect with the Kubernetes cluster. Okay, so now we need to run one or two commands on a worker node just to reset the pre-flight mode. So first of all, as I'm a root user, because it's good if you can just run it as a root user or the regular user on a worker node. So this is the command just to reset. It's refreshing the cluster. So because we are now generating the token on a master node, and then we will connect the worker node with the master node. So now back to the master node, and now I will generate the token. So let me clear the screen. And this is the command which I'm copying. And this is the command. It's a Kubeadm token create command, which will just generate the regular token on a master node. And we will use this token when it's generated. We will use this token and paste this token to the worker node, and it will properly connect the worker node with the master. So so run this command, and it will generate the token. And you can see that there is one warning. It's please ignore it. I think it's not a big issue, but this is the token, Kubeadm join token. You can see that this is the private IP address of my master node. So this is the 6443 port. I will show you one error when I will use this token on a worker node. So then I will explain you what's the purpose of the 6443. This is the token which automatically created. So I just need to copy this token from the master, and I will use and paste this token on a worker node. But I'm just copying pasting it here, but I will add one thing. This is the verbosity to view the proper logs. Whenever this command is executed, we will line by line getting the proper output. So just run it, and you can see that it's doing something, validating and everything. But when we should have one error here. It will time out error. You can see that it's canceling the request, failed to request the cluster info, trying to get this API. Because as you remember that I just created the EC2 instance. I didn't, and I'm creating the security group, new security group as well. So I need to open the 6443 port on my worker node security group. Then it will, because at the moment it's not a worker node security group, because I think the same security group I'm using for the both of the machines, so it's not having an issue. Because 6443 this security group is attached with the both master and node worker EC2 instance. So when it's connected, and then you should have the successful message here. Yeah, it's done. Because you can see that when I just opened it, then it will proceed to the next step, and it will says that the kubelet is starting, because the kubelet is the actual thing which is allow and the communicate with the API server or the master node, and then it will properly create. And when the kubelet is running, then then the worker node is able to communicate with the master node. So everything is done, and it's saying that you should run the kubectl get nodes command on the control plane, and then you will have the information of your worker node as well. So I'm just running the same command here, and you can see that my master node is the control plane. I'm sitting at the moment and running this command, and this is the worker node which is also ready. And if you try white command, then you should have the proper IP addresses. You can see that. Let me just, you can see the 1459 is the master node, and 12123 is the worker node. So let me show you on an AWS console. You can see that the private IP address of my worker node is 12123, and the master node private IP address is a 1459, and you can see that 1459 is the master and 12.123 is the worker node. So I think our cluster is ready, our master and the worker node is properly communicating. So this is the major part which we already done. Now we are able to deploy any application on a master node, and it will create a pods on the worker nodes. Let me show you as well. Okay, so now we are deploying the Nginx port on the master, and I will show you the actually pod is created on the worker node. So let me just clear the screen. kubectl, just I will show you. At the moment, I didn't have any pod. The Nginx pod is running at the moment on my master node. You can see that at the moment on the default namespace there is no pod. So let me create it. kubectl run Nginx. Okay, restart always command is just it's not important, but it will this prop flag is useful whenever your pod is crashed on or deleted or anything happened with the pod. It will automatically recreate it. So I just it will restart it and recreate it. So we will avoid the errors and we will avoid the issues with this command. So let me show you kubectl get pods. Pod is created. It's creating. So I think we should wait. Yeah, it's done. So let me show you the kubectl describe command. This describe pod nginx. Okay, so you can see that pod is created. Image is nginx. Latest version is there, and here is one important information. We should have the node. You can see that the node name is worker and the IP address is 12.123. As you can see that in a worker node, we have the private IP address 12.123. So it means that this pod is created and it's running on the worker node. Now the cluster is ready, and I think now we are able to deploy any application on it. This is good cluster just for the testing purposes. If you are wanted to just play around, play with the Kubernetes, then this is a good option, because whenever you perform your task, or you don't have much time to complete it, but you want to avoid the billing, you just need to go and stop these instances, and then your billing will be stopped. Whenever you are free and you wanted to perform and continue your learning, you just need to start your instances, and then you can able to access it, and the cluster is ready. You just need to use it, and you can deploy your applications. So let me create the deployment file as well, and I will show you with 2 replicas or 3 replicas, because at the moment we just have a single worker node. So it's not a proper example if we create just 2 or 3 replicas. It will just create it on a worker node, single worker node. So whenever if you wanted to learn or create a big cluster, you can create a more EC2 instances, and then just generate the token from the master and copy it to the worker nodes, and then they are able to communicate. But this is all the process is manual. But if you are using the EKS cluster or any cluster on the cloud, then you can easily scale it. At the moment you are scaling it manually. It's not an automated way. So this is the difference you have to understand. Okay, so let me delete the pod. Get pods. Let me delete this pod and recreate pod with the deployment file, just to show you the proper declarative method. The pod is deleting. So now I'm just creating the directory my app or something. It's not important or it's not needed. You can create your deployment file anywhere, deployment.yml. And I have the deployment file on my laptop. Just need to copy paste to avoid the time waste. Okay, so let me explain it. The kindness deployment, you can see that this is the version, metadata, any metadata you can set it, but this metadata is important to use it. We are using in our template. And here you can see that the name or of our container is Nginx, and the image is Nginx, the latest version we are using. The container port, inside the container, we are using that port 80. And this is the replicas. If we have 2, 3, 4, 5, or any worker nodes, multiple worker nodes, then we can increase it. But at the moment, I just have the single worker node. I'm just using it one, so it will create it on a this worker node. And this is the selector. This is the selector app. We are using the same label. I'm using it. So I'm just using this file, and you can see that the file is there. Run the kubectl. We have two options: use the create or apply command. So it's up to you. Apply -f deployment, and you can see that kubectl get pods, it's running. And you can see that the name of our application, which we have defined in the deployment file, and this is the deployment. So we can see that kubectl get deployments as well, because deployment create the deployment, and it will create the pod as well. And remember that the deployment is also created the replica set as well. If you run the kubectl get replica set, and you can see that the replica set is there, because whenever we are defining the replicas 1, 2, 3, 4, it's created by and scaled by the replica set. So you can see that. So let me show you the node kubectl describe pod, and our pod name is it's there, pod, and this is the pod name. And you can see that here the node is the worker node. And we have another method. We have another command to show the nodes, our pod, where our pod is running. So we use the kubectl get pods hyphen o wide. This is the command. You can see that it will also show the IP address of your node on which it's running. So you can see that it's a IP address of the pod. So this is the pod is running on the worker node, and our application is properly running on the port 80. At the moment, I didn't create the service. In our upcoming session, I will create a proper service, and I will deploy the big application on this cluster, and I will show you how we will create the deployments, secrets, config maps, the services. We will use the cluster IP type, node port, or the load balancer. And meanwhile, I will show you how we can use the secrets, and the proper persistent volume and persistent volume claims, how we will use it. So that's all from this session. I will share all the commands, all the details in the description. Please like this video. If you have any question, please ask, and subscribe to my channel. Thank you so much.